So first is the system overview. So this may be a repetitive one, but still for people who are new to this 15 RNH system, we have previously we used to have 1513 and 1515 R in the R family, and in 15 H family, which is the high availability of 15H family, we only had 1517 H CPU, but with version 17 we also have this 1518 HF CPU. And as you know that in the case of synchronization for 1500R, it is basically via Profinet, and in case of 1508 CPU, it is via the optical link H-sync modules. Switchover time for 300, it is less than 300 milliseconds for 1500R, and it's less than 50 milliseconds for switchover time for 1508 system. Apart from that, the different IO systems, like normal standard IO systems of 1500, like 1500 8200 SP, 8200 MPs are supported with both 15R and H. And in case of 1500R, the limitation with standard optical Profinet cable is 100 meters. But if somebody goes with an media converter, can somebody mute their mics? If you have any question, you can just type it in the chat box. So if you want to go for a longer distance with five media converters, we can go up to 3 kilometers. And in case of 1500H, like our earlier controllers, we have 10 meters and also 10 kilometers configurations can be done. In both the devices, Profinet devices of NAP S2 and S1 means are supported. Means supporting the devices which are supporting S1 and S2 both are supported. And for 15.6 means our CPU, it is recommended to use 16 devices in the ring, but it is not like restricted. But it is recommended to use to get the perfect synchronization between the system and full optimization of the working of the CPU. Then it is 16 devices are recommended, including the 2 CPU. And in case of 1508 CPU, it is a limitation of MRP ring, that is a 50 devices inside the ring. But if we want to go outside the ring and inside the ring, in case of 15R, it is 66 devices, and in case of H, it is 258 devices. But there are some new features. This is just a refresher, but you will see what all different configurations or what all different things has to be kept in mind during the programming of 15R and H you will see today. So it's little bit different than the normal standard part. So as many times we have already mentioned, so this is the new CPU with the failsafe system. So previously, still version 16, there was no safety system available for 1500 RNH, but from 17 onwards with 2.9 version and 1518 HF CPU, we can have the failsafe system, and the memories are 9 MB code memory and 60 MB. That now coming to the system redundancy and the different network configurations. This is very important because during uh, the checking of your configuration, you can keep all these things in your mind, and this will help you to configure the final architecture. So just to show you, 8200 SP and MP is by default there, but as you know, now there are different shortages of material and other parts are going on. You can also try with maybe eco PNP, because this is also supported from firmware 1.2. And there are PNP and couplers which are supporting S2 devices. These are basically the list of S2 devices which is supported with 1500 R and H. Apart from that, 8200 SP HA is also supported. I will show you in more depth what all things in SP HA can be done in the upcoming slides. So this is 1500H case. It is almost similar. You can put any devices, whether it is a S1 or S2 device in the ring, doesn't matter. And you can put devices inside in the, just I'll You can put devices in between the CPU also, because in this case the H sync happens between the optical fiber or the sync cable. But in case of 1500R, this H sync data is passed over Profinet. So it is by default recommended or mentioned in the manual. You will see that these two, within this two CPU, no devices are allowed, whether it is a S1 or S2 device. At least two connections should be direct to CPU, and in between the device, other devices in the ring, as other devices in the ring, it is not, S1 devices is not recommended because it does not support this H-Sync telegram. So S1 device is not recommended, as because if the cable breaks in between these two CPU, then the H-Sync will pass from here, and the S1 device will not support that H-Sync, and this will cause a synchronization issue. So for that reason, no devices are recommended not to put any device in between the two CPU. So just to show you how the configuration, if you are working with 1500 RNH for the first time and want to do the configuration, so it's not like a rocket science. You can do it in some simple steps. So I'll just show you this the part. So once you select the CPU, you can drag and drop into the network view area, and then you can see in the device view both the CPUs appears directly. So you don't need to individually select a CPU. Once you select RNH, R or H, any of this, it will come with two CPUs, and you can just select the IP of the individual CPUs. And once you go inside the program, you can see here that there are only programs can be written in the first CPU, and the second CPU will have no programming options. So once you have done it, you can directly detect all the Profinet devices which are connected. If all the devices are connected with the hardware, you can detect it, or else you can configure it like the normal configuration that we do. So once you detect all the different hardwares which is required, so you can just select it and all the devices will appear. And individually for connecting the devices, it's very easy. You can drag and drop and to each and every CPU, or the easiest, and you will see here there is a multi-assign coming appearing here. Another option is selecting directly and double clicking on and selecting those particular CPUs. You will get a multi-assignment also, or individually drag and drop. So both the options are there, and you can see all the CPUs are appearing here. And now if I want to connect another CPU which is not having S2 connectivity or 1200 CPU, then I can use a PNPN coupler, and in one side of the PNPN coupler can be assigned to the 1500H CPU, and the other side can be connected to the S71200 CPU. So in this way, once it is done, you can see the IP addresses are appearing in the system. So this was a simple configuration, how we can do the configuration of S71500 RNH. So what are the different Profinet devices and how you can put those Profinet devices and what are the effects? So now if there are two devices, one is S2, one is S1 device. So now if it is a S2 device, then it can be directly put into the ring and it will have a bumpless switchover, because S2 devices support the connectivity to both the CPUs at the same time. So whenever there is a changeover from primary to backup, then there is no effect on the IOs because it is having a bumpless switchover. But if it is a S1 device, then it can put it, you can put it in the ring in case of H, but it will not be bumpless because there will be bump, because S1 device does not support that part. So it will restart and check for the new available master in the network, and then only it will connect to that, and that will create a bump in the system. And there is another option that you can have a PNPN coupler, and with that you can have a subordinate controller, and this controller can be connected to the 1500 RNH, and it will run the 1500 RNH. So this is the the S1 devices. So you can connect the S1 device with the controller. For example, if we check, see like for example, like G120 drives does not support S2 redundancy, but S120 drive supports S2 redundancy. So S2, if it is a G1 S120 drive, I can put directly on the ring and it will support a one-place connectivity. But if it is a S1 G120 drive and I want a changeover which should not affect the process, then I can have a subordinate controller and put it with a PNPN coupler, and the drive logic can be written in the PLC and it will work. So just to see uh, how the configuration for some typical configuration which is required during the 1500 RNH commissioning. So just we will see that part. So once this network configuration is done, we have to go to the topology view and we have to define the topology. So once this topology can be defined by hand, or there is an option that you can directly upload the configuration. So you can, there is an option called compare, and you can select the your Ethernet adapter. And once the Ethernet adapter is selected, in the right hand side most, you can see here that there are some changes. So you can just apply to all and then synchronize. Once you synchronize, all the different configurations appears here. So no need to individually create, because in sometimes if the cables are wrongly configured, then it will give you error. So if you already connected the devices, you can directly import the configuration in the topology view also. But once it is done, then we have to define, by default the manager for 15R and H is configured, and it is configured as auto because here two CPUs are basically managers, so it is auto manager. But for the different devices, you can configure it as, you have to configure it as client which are in the ring. And for all the device, the same thing, same rule goes on. So for each and every device, we have to define the um, client, whether it is working as a client in the ring or not. And another part is the watchdog time. Normally this watchdog time, as per the Profinet, it should be kept as 112, and it will give as a watchdog time for 224, and this is common for all. So once all these selections for each and every devices are done, you may say that okay, if I have 50 number of devices, it is is it relevant to do changes in each and go and change in every device? Okay, there is also a way out. We will see it at the end. There are some add-ons also where you can see how we can do those part, avoid those part, and use some other different things. So now connecting different controllers in the ring or outside the ring, or how we can communicate between the controllers. So there are different options. You can see three options are available here. One is basically the selecting it as a devices as a I device. You can select that controller as a I device and the communication can happen with the two CPUs, but communication is interrupted whenever there is a changeover between the two CPU. Another communication protocol which if you want a bumpless communication between the H system or R system to another controller, then you can use a PNPN coupler and this switchover will be a bumpless switchover. And either if you want to connect also the Profibus devices, because 1500R and H both does not support direct Profibus connectivity, so you can have a PLC connecting Profibus devices to that particular PLC, standalone PLC, and then it can communicate to the devices. And if this communication also you want, then PNPN coupler is the best solution. Or else you can use it as an iDevice, and another can be like open user communication. So writing open user communication block, you can connect to the CPUs. Now, in case of 15R and H, there is a possibility that it can have a different IP as a system IP and a device IP. So what is the concept of system IP? Many times we have already specified, but still system IP is very important because it's a feature additionally given with 15 RNH. Like in both the CPUs, normally first while configuration, you have seen that we have given this CPU as one IP, this CPU another IP. But to communicate with an HMI or some PLC, if I want to have a single IP, then I can define and enable with a single click. I can enable the system IP of the PLC, and this system IP is basically a single IP which is common for both the PLCs. So whoever will be the primary, the system IP will reside on that primary CPU. So if there is a changeover from this primary to backup, and this backup CPU is now the primary CPU, so the IP address of that is the system IP will automatically change to this backup CPU. Again, when the changeover comes from primary backup to primary, again the system IP will reside in the this primary CPU. So how to configure it? Just go to the CPU properties, and once you go to the CPU properties, and in under Ethernet address, there is an option called system IP. It is not enabled by default, so you have to enable it. And once you enable, you will get a separate IP, and you can see there is a separate MAC address also. Here you can see, and now I am putting a comfort HMI inside my network connectivity and connecting the same to the PLC. And once I do the connectivity, I don't need to check because here I am using the system IP of the device. So the connections will be made under one IP only. I don't need to have two IPs. So I don't need a script. I don't need any other IP. I can directly connect with the system IP itself. You can see here. Enabling that will help you to get the system IP configuration. So that is why in case of 1500 RNH, you can also uh, connect basic panels with 15 RNH. So you can see here the connectivity is also made, and you can see the diagnostics inside the PLC and other parts. Everything can be possible. So this is the behavior. So whenever I have once configured it, so and a PLC is communicating with the primary, and once there is a failure in the primary CPU and there is a changeover happens to the backup, and the backup is now primary, then the CPU is still communicating, or the HMI is still communicating to this device, as there is a no droppage because of the system IP. So you don't have to check, sorry for that part. Another possibility of connecting is the device IP, and this in this case a device IP is basically the individual IPs to be configured. And sorry, this is in whenever we are using a device IP, in that case the synchronization times becomes more because communication happens between primary and the other PLC, and there is a basically the data is received, requested, and data is received, and the third part is basically the data synchronization. But in case when we are using a device IP via sync, so what happens is data is forwarded. First part is data is requested, then two is job is synchronized, and third part is data is received, and the fifth part is data is synchronized. So the rest data synchronization happens after two steps, so it will increase the higher synchronization load in the system. Safety for redundant system. So now, as because we have this 1518 HF CPU, so we can directly connect safety devices in the MRP ring, and using this ProfiSafe IO devices or safety applications, so running in the main CPU and the controlling the system can be done directly. So no need of a separate PLC in this case. But it may happen that my application is very small and I don't want a 1518 HF CPU, but for a smaller section of the safety part, I can have a separate CPU. So that separate CPU can be in the ring, and the non-safe communications means the safety program can be written in the safety PLC with the safety IOs and controls, and the non-safe communication of the F controllers can be communicated via iDevice or a open user communication. And this here, no safety program will be written. All the safety program will be written in this part. So this is another option. Another option can be, which is having more availability. In this case, the communication is, as because in the previous case is, it is either via iDevice or via open user communication, so it is not a bumpless communication. But if the customer wants bumpless communication between the two CPUs and also a more higher availability, then what we can do is we can have a PNPN coupler, only a single PNPN coupler, and then connect the safety devices with a safety controller. So that will also work. But there is another option that with two PNPN coupler we can have a, this is optional, this is not mandatory, but if the customer wants a higher availability, then we can have two PNPN coupler and then make a ring in between, and this will have a more availability in this case. HMI connections, you have already seen this part in the demo. So HMI can be connected via system IP also. So that is why basic comfort, all the different types of panels can be connected to 1500 RNH. But if I'm connecting through via X2, there is a possibility that I can connect via X1 port, I can connect via X2 port also in case of 1515R or 1517 and 1518H CPUs. So, but if I want that to have a possibility of primary, means this if the primary connection cable fails, this connection it interrupted, then there should be a communication to the second CPU. For that, there is another extension I will show you. This is an add-on application, so this you can use it, so it will change this primary to a backup. I'll show you later on my upcoming PPTs. Then apart from the system IP, because system IP I've seen, the another option is can be using the device IP. But it in case of WinCC 7.5 SP1 or SP2, the recommended communication is device IP, not the system IP, because in most of the cases it is observed that during the sync up of the CPU, means when a primary there is a failure in this primary CPU and backup becomes primary, and again after some time the primary CPU comes into picture. Now a synchronization happens between both the CPU. At that time there is a communication loss between WinCC and 1500 RNH system. And it is observed that if we are using a system IP, then it can be that during that sync up time that can be more, for only in case of WinCC I'm saying. But in case of using a device IP with a script, then the time is lesser than the normal system IP behavior. But in both the cases, in case of WinCC OA, there is no scripting required, because by default there is a scripting always used in WinCC OA. But in case of 7.5 and panels, you can use it with a device IP with a scripting, and there is an application example also available for that. And if you want a redundant communication, so in this case this was a single communication to both the system, but if I want a redundant communication, so that is also possible. Means these two CPUs are communicating with WinCC 7.5, and there is also an application available, and this is also via device IP. Another option is like redundant networks. In many cases, during checking of the configurations or customers recommendation, that the customer want a redundant network. In that case, we can also have a redundant network with device IP. In this case, what we or a system IP. Basically, we can use a system IP also. So what we can do is using a CPU X1 or X2 port in case of 1515R, because in case of 1515R we have two X1 and X2, both options are available, and 17 also, both options are available. So we can use system IP in X1 and system IP in X2, and then connect to WinCC or WinCC OA. In case of 1518, by default there are total 3 IPs available, X1, X2 and X3. So we can leave X1 for the IO devices and X2 and X3 can be communicated via. So the configuration which you are seeing here is basically the X2 and X3, which is of 1518 HF CPU. Coming to the installation recommendation. So this is after getting different queries and different configurations, we have seen that different requirement comes for whether it is R or H, what type of requirement comes. So on depending upon that, we have made some architectures which is will be helpful to understand. So for a cost effective solution and where there are less number of IOs, normally people go for 1513R. And in case of 1513R, what are the different possibilities? So the first possibility is like we can put S2 devices directly in the ring. And if I want to put a S1 device, I can put it via switch and put it in a different network. Not different network, but with a switch, I can put the S1 device. Another possibility like communicating the basic or comfort panel. For basic panel, as because there is no possibility of MRP in basic panel, then we can directly put it via switch, or we can use ET200 SP HF-3, which is having 3 ports. So two will be in the ring and the third port can be connected to the basic or comfort panel. So this solution is very helpful in case when we are using it in the with a application where the HMI is mounted in some remote section. So you don't need to have a switch here. You can directly put a HF-3 and connect this basic and comfort panel. Apart from that, for the other devices to communicate on bumpless with 15R and R, then you can have PNPN coupler and connect the controllers and then IOs. Another new feature which is recently also tested, I think from 16 also support and 17 by default supports, is putting comfort panel in the ring, because many times we have got queries that okay, I want to put this as a ring and I don't want to invest separately as a switch or put it as a HF-3 because I have only one HMI in my configuration. So now comfort panels can also be kept in the ring in case of R also. So this is now supported. And for this communication between the PLC and PLC, open user communication is possible, and as a iDevice also possible. Another thing that was mentioned in the first present PPT, the configuration, that maximum 16 devices in the ring. But this 16 devices is a recommendation and it is not must. That means 16 devices means if I leave these two CPU, so 14 devices can be put into the ring. But say for an example, in one of my a case which came to me as a for approval, there were some remote IO stations with maximum one DI card and one DO card. But there were around 36 or 30 stations, 1800 SP stations, and they wanted 1500 RS because there was a recommendation that at that time that 16 not more than 16 can be used. So we have to go to 15 17H because they wanted that in the ring. But this recommendation is it's a recommendation. It is not a restriction. But you can go up to 50 devices also, but it is not recommended because it can create a performance issue. So in this case, at least I think as per our confirmation from SAG, they have also tested more than 16 devices up to 18 device, 19 device. It worked okay. So if there are configuration with less number of IOs, you can also consider, but it has to be checked before confirming to customer, because there can be a performance because it's not recommended. So it's recommended was 14, but if it is less IOs, then you can try for that. It's also mentioned in the manual itself. So the same thing is true for 1515R. I have not shown the similar configuration because whatever was possible with 1513 is also possible with 15R. But only thing is, in case of 1515R, we have a separate X2 port. In this X2 port, we can connect the HMI. So it's if you not required to connect it in a MRP, you can directly put it in the X2 with a switch separately connected with NCC and other parts. And the rest of the thing is similar like 1513. 1517H. So here it's more flexible because the synchronization here happens in the with the optical fiber cable, and so I can have S1 devices also inside the ring and up to 48 devices, means including the two CPU it is 50 device, so excluding the CPU it is 48 devices can be in the ring. And apart from that I can have open user communication like 1515R. I can also connect the other devices over it. uh, this is another option for 1518 CPUs. So if 1518 CPUs already have that X2 or X3 port, so I can have a redundant network in this case. By default, keep in mind CP cards, extra CP cards are still not possible up to this released version. So if you want a redundant communication without a CP, then you can use 6 to X3 ports, or else using system IP and 1515 or 1517, and then connect X1 and X2 to WinCC. Okay, there are some programming recommendation. It is more for the engineering team who are doing it. This is a recommendation. So some of the things are like adjusting the maximum cycle time. By default, as also discussed with our SAG team, we have found, means our headquarter team, that we have found this is mostly they don't touch this part, maximum cycle time, but this has to be kept in mind that the maximum cycle time when during the sync up, basically these all these adjustments are during the sync up, because during sync up it takes, if the these settings are not perfect, then it can take longer time. So the adjustment of maximum cycle time, it should be greater than 80% of the maximum cycle time. So the actual cycle time is less than 80% of the maximum cycle time. It should be like this because it takes maximum cycle time of the program, and this is the downtime during the failover, and there is a reserve also. But this, most of the time you don't need to take care, but this part has to be taken care. That is to set the minimum cycle time as high as possible, and just not go by numbers. But in case of H it's not issue, but in case of R mostly it is seen that if possible you can keep it up to 50 milliseconds for the minimum cycle time. But if you, in the next slide, if you see, there is 38 millisecond is given, but if possible you can give, if in some cases that you need to go come little bit lesser, you can go up to 10 milliseconds also. But to get a better behavior you can keep up to 50 milliseconds. And this is a wait function. So a wait function can be written in OB1 at the end of OB1 basically. So once it is, there is a breakup and the synchronization happens in the first cycle, it will go and check for the wait, and it will wait for up to 38 seconds and then come to the next part. So it will freeze for 38 milliseconds and then come to the syncing, scanning of the program. So this can help the sync up of the CPU time. So these were some of the do's and don'ts, but and some more are also there. But apart from that, some new features which is from 17. Already some of the features we have already seen. I'll not highlight on those part, but some of the features are very much useful, so we can highlight on that part. So first is this safety CPU. I have already said many times, so I'll not go in details. So 1518 failsafe and high availability CPU is already there. And so configuration example also you have seen all these different configuration, whatever safety program running, and communication from with another safety PLC can also be there with the X2 port. And if the safety functions, like if you want to use the safety functions, then enable, you have to activate this part. But in some cases nowadays there is coming that I want two communication ports separately, and the IO ring will be separate. Then in that case you can also use 1518 HF CPU without using the safety part maybe, and you don't enable the F part. safety part, and you can use it as a normal redundant CPU, not the safety. Very important part now is which is basically the MRP interconnect. As already mentioned, this is a limitation of MRP that we can have maximum 50 devices in the ring. But if I want to have multiple rings, then what to do? If I am not having a CP card and I want to have multiple rings, then what to do? So then the option is basically MRP interconnect. And this MRP interconnect is basically, you can see that there are, this is one type of configuration where the CPU is there with a single ring, and there are four number of switches here and four number of switches here. So two in the ring and then connected to two switches, and this switch is again a ring manager for this ring, and these two switches are the ring manager for this ring. So in this way you can have 50 devices in this ring and 50 devices in the other ring, and you can make multiple rings. Apart from this configuration, there is another possible configuration where, like, this you can think like using a separate CP card. So how is it? Like, I have two switches in the ring, and then these two switches are connected to both the rings again. How? Like, the first switch is connected to the first ring, the second switch is connected to the first ring again, and the first switch is again connected to the second ring, and the second switch is connected to the second ring, second switch. And in this way the availability is more. So if in any case, say for example, this cable fails or there is a error in this cable, so what happens is, still I am connected to this ring via this switch. In this case also, if my cable, and same happens for the other ring also, because this switch is failed means this communication is not there, but still the communication with this CP card, this switch is available, and so both the rings are available to the main H system. Think in the alternate way, like if this switch fails, still my this switch is available, so the connectivity with my ring is still present with H CPU. So this is giving you more availability part. Configuration wise, how do we configure this MRP ring? So normally we have to configure two or three rings depending upon my requirements. So in the first ring, for example, think of like this is the first ring and it is having this number of devices, and in the second ring there is another device which is having a switch as a master. So what we can do is we can go to the ring configuration, and by default this in the first ring the ring manager will be the CPU, which is by default selected, and you have seen also during when we have done the configuration. Now coming to the second part of the ring, so you can declare it as a ring 2, and you can say redundancy manager outside the project. So if it is outside the project, so this part can be defined by a web interface of the scaling switch. So you can define the scalens in the scalens, go in the web page and define the ring manager and the ports required for the ring MRP ring. And once you compile after doing all the hardware configuration, you will get a warning, but that warning, it mentions that a manager must be configured in the MRP domain because it is not configured here. So but by default we are doing it outside the system. Next part, PLC Sim Advanced, you have already seen during our previous slide that in with version 17 and PLC Sim 4.0, all the different HCPUs and RCPUs are supported by selecting the drop down. This is the feature that I was telling you about, like what happens during a failure in connection between the HMI or the SCADA. So previously this RH control block was only having disable sync up or enable sync up. But now with version 17, it is also having request sync up, stop primary PLC, stop backup PLC. So uh, disable and enable is basically like stopping the sync up or enabling the sync up. But in case of request sync up means you can start the sync up at any time. Sorry, or stop the primary. So for example, if I'm checking the connectivity and my primary is not connected, then what I can do is I can stop the primary CPU, and the system will run into run solo mode, and this primary backup will now become primary, and it will be connected, and after that I can again put the backup into the run mode again. So this is the option that was shown previously about the RH control. Then another thing is like now with version 17 and firmware version 2.9, the S1 function of means the switchover function of S1 devices has improved. So failure time now is improved with S1 devices, and this is the function how it happens. So in the first system, you can see the system is in state of run redundant, so all the system is running healthy, and the S1 devices is connected to the single application relation. AR is application relation, and now a failure happens, and after the failure the IO still holds the connection until the configuration watchdog time is over. During this time no additional connection is possible, so the system is on hold. Now the second part is IO device is now ready for new connection to the IO controller. So the new controller is now prime, the backup has become now the primary. Now a new connection is established, the IO device now begins the startup, and once the startup is done the IO data are exchanged again. And this is how the thing is like previously with for the S1 devices in version firmware version 2.8, it was like basically the timing, watch timing behavior failsafe not adjustable at that time, activation of new and IO device specification startup happens. But in case of firmware version 2.9, this is basically tested in some special scenario. Don't go by the numbers itself, it is tested in a particular scenario, and they have found that with 1517H and connecting with the S1 devices, previously it was the at the similar scenario with 2.8 it was 3 seconds, and this with 2.9 now it is 0.6 seconds, and this has this adjustable watchdog time, and we can get a short time during the I-device communication of CPU. So think of like a 1500H system connecting to a standalone 1500 with an as an I-device, and this is the time. The previously it was 3 seconds, now it is 0.6 seconds. This is a very important feature came with version 17, that is OB72, which is the H-sync redundancy loss. In case of 1500H, previously it was like if as because you know in case of 1500H system, if a sync cable fails still the synchronization is available, and the you can switch over from primary to backup and backup to primary without having the second cable still, but the maintenance LED will glow only with, but it is not known to somebody unless and until somebody is going to the PLC panel, they will not able to know that whether there is a error or not, because only that maintenance LED is going. But to get an idea or create an event, you can use OB72, and it will be called during the sync cable failure. If one of the sync cable failure, then you can write some program, give an error message, and people can go and check what is the problem, and they can change the cable or the sync points. So the next part is basically the same thing which we have already seen in the new features of 17 in the security part, and security is important. I'll not go in details because most of the thing we have already covered in the 17 slides, the previous uh, section. So it is mostly like if I want to have a communication security between the CPU and the communication with HMI, all this thing, and with TI portal and WinCC. So that is also possible with 15 RNH. So secure communication is now possible. And as the similar like 1500 standalone 1500, here also you have the option of configuring the protection level. Whenever you select, you can configure the protection level, and while downloading it will also have that certificate and password protections. So apart from the standalone CPU, here it is little bit different than the standalone one. So now in case of RNH CPU, it is something like first the download, and you have to download and set the password in CPU 1. Then once the CPU 1 is set, you can set the password for CPU 2, but at this time there will be a sync of failure happens. And once the start, you start the system again, the program configuration is synchronized, and now it will be healthy. The question may appear that what happens if something fails, I'm connecting with a new one. So exchange and deactivating of RH CPU. So once CPU fail and gets deactivated, so exchange of CPU and password again. So what happens is the CPU has failed. Now I want to exchange it. So I can alternately I can download the failures site, and at that time the similar thing will happen. This will not be in a sync up mode, and I can download it, and my system will again come to the run mode once it is downloaded. So these were basically the parts which were new with version 17, but there are some features which is mostly available in our support side. But I'll just highlight so that whenever you are getting this type of query, or if there are some requirements, you can just go through this application example and check if it is meeting the requirement which is asked by the customer or not. So the first part is now with version means the new Simatic automation tool, we can also means this is from version 4.0 SP3 Simatic automation tool. Redundant controllers are also supported, and this allows that you can update the firmware or user program directly by using the Simatic automation tool. This tool is very helpful in case if the machine is sent from one country to another or one state to another, and you want to only do the downloading of the new modifications. So using this Simatic without having a TI portal, you can use the Simatic automation tool and download or upgrade the firmwares. And this information is available in the given CIOS link. This is another very interesting and most used functionality or a block. This is a diagnostics of the operating state of S71500 RNH, and this gives the programmer to get all the different states. So it is a ready to use block, and it gives all the states. So whatever the operating state of the CPU, and if I want to show it in the HMI, if it is running in a run solo mode, whether it is in a sync up mode, where which one is primary and which one is backup, all these things can be shown by using this particular block. And the block and application example is also available in the given link. Now the interesting part is the remote redundant IO. And this question comes many times, that whether we can use redundant IO in 1500 RNH or not. Yes, we can use redundant IOs, but not by hardware configuration. These are basically blocks. You can configure these blocks for redundant IOs, and it is not that only you can have it like in two IEMs. It can be in the single module also. It can be side by side module also. It can be in two different racks also, because you can configure it in the TIA with this L redundant IO block. Only thing to keep in mind is that whatever the modules we are using, that module should support module status value, because that is required while using the L redundant blocks. And I think in most of the cases, if it is HF module and ST module supports the status value, but basic modules does not have that status value. So If you are using a 1500 R or H and using modules, you can use it with HF and ST, but there are what are the limitation and how you can use all these things as given, and this is true for all, whether it is DI, DO, AI, AO, all the modules can be used as redundant modules. The wiring diagrams, the configuration and everything is available in this given application example. At the starting also, we have seen one module where what are the different modules supported or different IM supported, and you have seen that 1800 SP HA is also supported. I know there will be some questions in some of your minds that okay, HA is supported, that means R1 redundancy will also support, that means two IMs, but no, it is only limited to S2 redundancy. So simple S1 system or S2 system can be configured, not as a R1 device. So you cannot think like, okay, I'll use 2 IM and use it, because most of the cases this is the requirement. Still now, with the release version of version 17, redundant IM, or means redundant IMs, it means 2 IMs in a single rack is not possible. It is awaited maybe in the next version, but we cannot confirm at this moment, but it is going to come. But with 8200 SP HA also, you cannot use it as a R1. It can be used as a S2 device, and you can configure it as a media MRP connectivity and use it. Next is the portion that you have seen during the configuration of IMs or the IO devices. We were selecting individual watchdog times and changing them. So you may say that okay, this is very hectic. I have a big system and changing each and every one is little bit hard. So this is having an application example already in our support site. You can directly go to that application example and download it, the add-on. Like in case of Pankaj, he has already shown you for VCI there is an option of add-on for connecting VCI. So you can download and add it in an add-on. Like similar like that, you can have an add-on in as 1500 TI portal for 1500 RNH, and this add-on will help you to do multiple configuration of watchdog times and in a single window. So you don't need to go individual modules and do the change. Long awaited, this was already there from version 16, but for different application depending upon water, wastewater, and where the communications are required, metro and other applications where there is a requirement of IC 60870-5 101 104 and DNP3. All these things now is with TM 1513 IRC, it can be used, and configuration wise it is also given how you can use it, because the main configuration will be in TM113 IRC. Then the C plus RIC library, which is basically the 60870-5 of all the versions, that it is 101, 102, 103 and 104, mostly in the substation automations and other parts. So you can use this library also with 1500 RNH. Then 61850 for relays. We can use this communication as a client library, 61850 as a MMS. This is can also be used from version 16. This is for the Modbus TCP redundant library. So this is also possible with S71200 and 1500 and also 1500 RNH. So if there is a Modbus TCP redundant communication, and you can, if you want to use that block, and this goes for a cost, so you can add, because this is a licensed one, and you can add this redundant block and use Modbus TCP communication, because in many cases for communication with DCS and other third-party devices, customer ask for a redundancy in Modbus TCP. So with using this Modbus TCP block, we can achieve that part also. And for redundant open user communication, there is also an application example where it can be used. So all the different redundancy possibility you can see with the different libraries is possible and available in our support site. So finally coming to the restrictions part. So These restrictions are basically the version 17 restriction, and it is still there. And maybe we are coming up with new versions. Maybe some will be coped up, like central use of modules, IO, CM, CP, system power supply is not possible. Okay, system power supply is not possible, but there is also a possibility of power supply redundancy with using our diode module available in that is configured in the TI selection tool. You can use that module and use it with 15 RNH. Profinet network structure. So only MRP is supported. Open ring is not possible with 1500 RNH like you do it in 400 RNH. Use of RH system as a shared device or older I devices not possible. Use of Profibus devices, it can be used only via a coupling by PNPN coupler. Not at this moment, there is no possibility of using a PN um, TP coupler. So then S7 communications. S7 communication as a server, it is possible, but as a client, it is not possible. So you can configure S7 communication in the CPU, and the other CPU can be the client, and it can take the blocks has to be written in this other CPU, not in the 15 RNH CPU. It can work as only as a server. OPC UA and web server is still not possible. System supported edge communications blocks or system supported redundant IO is not possible. Redundant IO with block is possible, but system supported means with IO configuration directly in the IOs is not possible. Like if you remember in 8200M, there were modules, but with this 15 RNH, you can do it via blocks. Technology objects, some technology objects are possible like the PIDs and others, but not the motion controls. Then the support of MRPD, clock synchronization, and IRT is not possible. Hardware extension in run mode, this is not possible, but with IO link, this is true for 1500 R and H also. You can use this as a during hardware configuration in run mode for IO link, not for the normal IOs. Firmware update in run mode is also not possible, and DHCP not possible.